All right, so I guess it's the time to start. It's 3 a.m. in the morning. You got paged because one of the services is down. Everything was fine yesterday, but looks like your colleagues from another time zone decide to roll out new version of the application that drastically changed the format of the data that you was consuming. So now you're on call, you're trying to figure out what the hell is going on, and you start seeing some weird bytes in a payload that you expecting something else. And this is how we end up in this talk, and this is how we end up in this conversation. Because polyglot environments where the people developing systems in different languages, right now it's very common. You have teams that write in Java. Anyone writing in Java in this room? All right, 3 people. Anyone writing in Scala? There's always one person. Why are you so shy? I saw you in another talk. You also were, like Sandon was asking, and you were like shy. I'm not going to be doing any offensive Scala jokes in this presentation, but come to me if you want to learn something to offend your colleagues. Not a huge fan of Scala, if you understand. Anyone Python? Node.js? All right, cool. So that proves my point that there's people who develop applications in different languages, and having some sort of polyglot way to exchange messages through Kafka, since this is will be talk about Kafka and Kafka architecture, is very important. Very important. So, in the good old days, what I mean by good old days, is when Kafka was written in Java. By default, Kafka client also ships in Java. People enjoy themselves writing their Java stuff. They ain't thinking so much. They just put this serializable Java object in Kafka topic. Kafka doesn't care. Kafka doesn't enforce. Kafka doesn't judge you. And they have some other Java developers on the other side that consume these messages. They also enjoy their Java serialization so much, so they don't care. That's the good old days. And all those systems, they will talk the same language. They talk the serialization in this binary Java format. And now someone decided to hire a Python team because now we're doing machine learning and now we're doing all AI stuff. Somehow people convinced that the Python is only language for AI, even though, as you know, 3 billion devices run Java. Anyone old enough remember the Windows installer from Java? When you install in Java, it says you know what? There's 3 billion devices running Java. Even more developers actually write the Java. But hey, we want to be diverse in our portfolio of the technologies that we use. So we hire Python team. They arrived in this ship, probably. After that, we also hired a Node.js team. We hired, I don't know, Golang team. They come in the different shapes or forms, and they enjoying the formats of exchanging the data, what was the natural and what was the available in their language. So we need to start dealing with the situation. And again, Java developers was like, yeah, but what do I need to do with this? And Java serialization was so good that we, in Java, invented tons of different serialization formats, right? So if the Java serialization would be a really good format, we will not come up with any new formats. No protobuf, no Avro, no Thrift, no Magic Pack, so far and so on. There's plenty of other serialization formats. And, Viktor, but what about JSON? Yeah, we'll talk about JSON as well. So now, since the system was written in certain rules, now there's some crashes, some of the issues happening. One system cannot deserialize and start losing messages. Another system decided to go with JSON, and they have a slightly different view on the way how they format with JSON. They're using different cases for their properties and so far and so on. So there would be very, very nasty issues that's going to happen. So our biblical the Tower of Babel, where we're supposed to be talking the same language, start collapsing because it's not that simple anymore. So, but don't be despair. There's hope, as always. There should be some of the light. And with this, welcome to from Tower of Babel to Babel Fish. How you will involve your Kafka architecture using Schema Registry. My name is Viktor Gamov, and I come from a company called Confluent, founded by the original creators of Apache Kafka, and we also do a lot of cool stuff with Kafka stream processing and all the things. I wrote a book about Kafka back in the day. Still, I think, cool thing to brag about, but probably it's already outdated because my Kafka in my book uses Zookeeper, but we don't use Zookeeper anymore. How many of you using Zookeeper these days in their Kafka ecosystem? Few people. It's fine. No judgment here. It's a safe room. We can talk about this. I'll give you a hug after. Give you a few tips how you can improve this. So no problems with this. Probably another very important slide, because all the content of this presentation, slides, links, demo, some other links will be available on my website, speaking.gamov.io. And also we have a camera in the room, so the video also will be available. I don't know if I will be able to beat the organizers because they're supposed to stream this, but I'll try to upload this even faster. All right, now, how many of you got the reference of the Babel Fish? How many of you read the Hitchhiker's Guide to Galaxy? All right, so in this book, there was a special device called the Babel Fish that you could put in your ear, and you start listening and understand different languages. So I can argue that this technology that I will be discussing today, Schema Registry, will be this, the Babel Fish for your system that allows you to your system speak the different languages, different programming languages can speak same data. So, what is Schema Registry? Schema Registry, it is a service that runs next to Kafka. Schema Registry provides API that different components of your microservice ecosystem or your event-driven ecosystem can interact with. There are clients available for majority of popular languages, so you don't need to write raw REST endpoints. Also, Schema Registry uses Kafka to store schemas. There's also a rule of thumb that you also probably want to remember from this presentation is that do not produce directly to underscore schema topic where the schemas will be stored. Even though you can, you shouldn't, because the Schema Registry API does some other things on top of it. For example, compatibility checks, enforcement of certain rules. So even though you have access to schemas, you can see the schemas registered in Kafka topic, you should not interact directly with this topic. So what is schema? Schema, it is a contract. It is something that you need to agree across your organization, different teams, and schema usually will be defined in some sort of intermediate language, meaning that it will not be depend on, say, Python, or it will not depend on Java. It needs to be something that normal people can understand, like product managers. Any product managers in the room? Good. So, because sometimes people get very sensitive when I call it like normal people, like, you know, who wants to be normal? I said the product team, meaning that it needs to be owned by someone who will have ability to make a last decision, because schemas is something that you establish as a collaboration and communication technique between your different departments. It's not like you cannot enforce certain things. You can say that, yeah, so you just use the schema or get out. It's not very nice, it's not very polite, and it's not what we do in these days, right? So because the DevOps and all these techniques of software development lifecycle teach us to collaboration. It's nothing to do about technology, it's about the human collaboration, how the human communicate. So schema will give great context to collaborate about this. Since the schemas defined in intermediate languages just a text, they can be versioned and can be reviewed. You can put the schema approval process through your standard tools. You have a Git, you have a GitOps, because you can put some of the automation on top of this. Once the schema would be approved, it will go through the pipeline and will be deployed into Schema Registry. So it is a tool to establish context across the systems. And Schema Registry is the place that will be storing those schemas, storing those contracts. Now, there will be a lot of demos, discussions, so I decide to cut some slides and go to talk directly about some of the functionality. So let me introduce my demo. And this is how I seamlessly switching to different microphone. That's a quick handoff. In this demo, I'll have few services. One service, what I like to call it, order service, that this is something that Java Spring Boot, this is where we're going to be producing our orders. Something can be exposed to your, say, mobile app or your front end. We will have inventory service that is written in Python that will be managing our data about availability of certain items for our order service. And we have analytics API. This is something that maybe our backend or some of our salespeople will be using to understand where we're standing in terms of how our sales are going. And this is one written in Java. This one is written in Python. This one is written in Node.js. So I'm going to start with the very simple. Oh, and let me also show how this ecosystem would look like in terms of what we're going to be running. Two components that I'm running here. So it's Kafka cluster running locally. Same would be applied, everything what I'm saying applying to any implementation of Kafka. If you're using Kafka open source, if you're using Confluent, if you're using Red Panda, whatever you're using, all the rules will be applicable here. Also, the Schema Registry is also it's a freely available system. You can connect to any Kafka implementation. It's a source available, but it's not kind of open source, but you still will be able to look under the hood at what is happening here. This version is running locally in my Docker, and if I go here, just refresh, two topics. As I explained, the Schema Registry stores all the schemas inside this schemas topic. You can sometimes peek inside and see what is happening here. And this is going to be my order topics where we're going to be collaborating and communicating messages. So right now, there's no messages here. So we're going to start with first scenario. Remember, I was giving you like a scary story about some of the Java people pushing the Java payload inside the Kafka. Let's take a look how this actually looks like in the real world. So if we're going to run with demo scenario 1, demo scenario 1 will go through a few things. First one, it's actually submit some nonsense here, and it might not be nonsense for those of you who can understand bytecode and stuff like that. It's actually Java serializable object of orders that land in this topic. Not so pretty, not so nice, and it's not very easy to understand what is happening here. So immediately we can see some errors. I'm going to explain these errors in a second in inventory service and analytics service. All these microservices, they run some of the form of like error logging. So for example, right now, the analytics service says that failure to parse message in JSON because their consumer expects this to be JSON. I don't know why they took this because, we're in Java, we're writing serialization in Java serializable. But they expected this, but they got something that they cannot parse. And also, let's take a look how the other messages would look like. So this one is kind of sort of looks good because it looks like a JSON and its key is a string. We do have something, and looks like there was not any issues for the service to reach analytical system. So the message with the ID, what's the ID was here? Order ID is 96. So 96, that's our first message. It's successfully created, so we can see this in our analytical dashboard. So let's see if our inventory service also sees this. It works fine because JSON is generally acceptable for the system to receive those. But let's take a look how this JSON would look like if I would take, say, this one. Is it same JSON? Let's compare. I think there's one of those should be add to compare. Where is it? Select for compare. And we're going to open, what is it, 73. Let's open 96. And what we'll do, will I be able to compare with selected? So it's all fine, it's all good. But you can see there's lots of discrepancies in order how the user information will be passed here. So there's no enforcement here. Also, sometimes people can put the strings here. JSON doesn't enforce this change for you. So JSON is generally okay-ish technology, but there's no the way how you can communicate around the schemas. Some of us want to have ideas about how we're going to store the order ID. It's going to be order and ID in a kind of like a, how we call it, camel case, right? Camel case. Or it needs to be like kebab case. People in Python use kebab case. Or snake case. Snake? Because Python, obviously, yeah. So that's the idea. So still, JSON gives us something that we can work with. Generally, we already good on parsing JSON in different aspects, but the part that would be important, not the technical aspect, not the actual, how good we are parsing JSON, but the part that matters for our application. Like I said, the user ID can be, maybe in a different form. We want to have a little bit more enforcement and control. So, in this case, you get the setting. We have three services. Now let's see how we can do stuff here. All languages that I will be showing and majority of the languages that we will be using, they have one of the ways how you can interact with Kafka. Either there would be client for a schema registry, or there would be some sort of like a library that allows to go direct, do REST endpoints. And the hardest thing is also we need to have ability to serialize and deserialize. So that's important. This is the best photographer for the conferences. I use these photos for my LinkedIn profile like all the time. So that's why it is important. Like it's important stuff. So I'm switching to now version of demo 2. In this case, the quick summary of demo 1, Java serialization not cross-language compatible. JSON field naming can be inconsistent, so camel case versus snake case, and sometimes can be type mismatches because, have you ever seen this presentation called WAT, what? When the guy explains the JavaScript quirks and what kind of like interesting, I don't know, it's a 15 years old presentation. I'm showing my age, but it's a great presentation to get a laugh on JavaScript and type system. So essentially numbers versus strings and all these things can cause some issues. Now, we're going with the schema registry solution with Avro. Avro, it's a serialization format that came from the world of Hadoop. And in the world of Hadoop, they need to deal with the data and evolution of this data. And also, I didn't even talk about how verbose is JSON, because every time when we need to put, say we're sending collection of orders, we will duplicating our information about order ID, all this like field names and stuff like that. So it was not acceptable in the world of big data because you want to focus on what actually matters, in this case, actual payload. So the schema was extracted, and Avro come up with some clever ways how you can support backward compatibility, forward compatibility, full compatibility. I'm going to talk about this in a few more minutes. Another supported format is, I mentioned protobuf. Protobuf is also quite popular for cross-platform communication that was created at Google, and after that it became the foundation for RPC protocol, gRPC. It's uses for describing not only payload, but also describing service interfaces. It's kind of goes beyond, but this serialization format is also very cool. It's binary format. It has a schema that is outside. It also supports schema evolution. And also speed. The binary formats, usually serialization and deserialization, especially designed binary formats, are much faster to deal with comparing to string-based format like a JSON. Even though we do have very modern and quite popular and extremely powerful parsers, the binary formats still beat the string format. Another cool thing with these binary formats is partial deserialization. So you can actually, if you don't care about whole message, you can have ability to get access to particular fields. So API allows you to do this because everything is just like array of bytes and you're just navigating through indexes. How you know this? You know this from the schema, and schema has like very strong like requirements or specification how these bytes would be situated. So let me quickly show, let's run demo 2. Meanwhile, while it will running, so we're gonna be submitting to special type of consumer that knows that the data will come from Avro. So in this case, Let's actually see if it's the data just landed. So we have this user 123, and if I'm gonna go and check my messages in my Kafka topic, it has now new format. For comparison, the value metadata here says it's JSON. Now it says Avro. Going here. So it has Avro, it has the key and value and stuff like that. Now, if I go with the schema, where is it? The way how the schema registry have a convention how the data would be stored, you can actually have a key serialized with Avro and value serialized with Avro. So that's why when it stores inside the schema registry, it will have this convention topic name dash value or topic name dash key. So in this particular case, we're interested in value, and this is how the schema would look like. This is human readable, more or less. Something that you can easily communicate across, come on, too many windows. Something that you can easily communicate across different departments. It looks JSON-like thing, but they just use JSON to describe the schema. It's not like it uses JSON underneath or somewhere. Avro actually has two ways to define the schema. There's a JSON style like this, and also there's a more not JSON style. So there's another one. I prefer use the JSON one, just simply much more simpler and easy to use. We can provide different hints for this serialization. For example, in this particular case, we can define some of the types, how Avro types will be mapped on particular type inside your language and your type system. So now we have these messages in order. We switch to Avro, everyone using Avro right now. Correct field names, no guessing. And also systems can use this schema to explore data in topics. So this is exactly the way how this plugin works, for example. Visual Studio Code plugin for your Kafka, courtesy of Confluent. If you want to pick it up, it's free and it's open source. So what it does, it reads the message from Kafka topic, and after that, it reads the schema, and this is how it parses this the binary data and displays this into the screen. Now, as I mentioned this a little bit earlier when I was talking about schemas can be used as a collaboration mechanism. It's the best example if you want to kind of automate the process of distributing the schemas and put them through a CI/CD pipeline, where the people who needs to change something or approve something, they'll come and work in a Git workflow. You see you have like a paper trail in terms of like what was changed, who was approving, and the things like that. You can have a discussion about how we're gonna name this field and stuff like that. Everyone will get looks good to me, and this is how we're gonna be approving schemas. And once the PR reviews, there are tools that allow you to propagate those schemas automatically. Another step would be creating the artifacts for your language. In Java, we are strictly type language. We're not dynamic language, so we would love to have classes during the compile time. So the tools like Avro compiler and different plugins for Gradle and Maven allows to create a Java object, Java classes out of schemas. And since it's auto-generated, you have a choice. Either you put in them in version control, or you create this, you update the schema in your central repository, and after that you kick off the build where those things will be created, and you just release new version of the jar. All these Java classes would be compatible with new schemas. Some languages like Python, they don't strictly require to be to have a compile time objects, but in this demo, if you will go and look in the code, I actually also use tooling to generate Python classes and JavaScript objects as well. So the usually it's from agreement, from a point where we agree about the schemas. It's the rest of the stuff is a very mechanical thing, meaning that it can be easily automated and easily can be pushed into the system. And this is what I was talking about earlier. Create types for your language if it requires, and publish them. You can publish an internal artifactory or Sonatype or whatever you have for managing your artifacts. Maven, NPM, and the PyPy. Let's talk about the compatibility. So it's very important where we're running these systems in multiple settings. You can have some of the components or some microservices that can be lagging behind. Your systems, your life cycle of your project is maybe not very well aligned with release cycle of your colleagues, of your the different departments. So you don't want to, first of all, don't want to break their stuff with releasing new things, but also they also need to be comfortable of dealing with data either old or new. So there's certain rules in terms of backward compatibility. So backward-forward compatibility is something that can be enforced on the Schema Registry. So backward compatibility means that your old consumers will be able to read new data. So your producers, your like operational system, in my case it's order service, when I change the values of this schema, it will recompile, and after that produce message I can kick off this compilation while I'm talking and explain how this would look like. In my Java code, where's my Java code? I just do a quick zoom. 50, and so my order service, which is Java, would have my Avro version here. So we're gonna go with the order event. It's the order. I have a version 2 that I can create. So version 2 will include some additional metadata. So I will include this here. And another thing that is you can see here, if you can see here, it's called generated. Order event has this generated Java object. It includes fields that we need to work with, but also includes some additional metadata that Avro will be using internally. So if I would restart my, I'm gonna go with my order service. I'm gonna go restart, and this will kick off build, meaning that I changed the schema on producer. I created new objects on the producer side of things. Now, if I will be submitting messages, these messages will include some additional field. Let me do demo 2 one more time, so it will just produce some messages. And what I should expect to see here, now it includes some additional order timestamp and metadata. So by default it's null because my code is not using, but its data is already there because I created schema, I regenerated classes, I just don't use it. By default it will be using null. Inside the schema I can also define a default value, so in this case it will end here. And also on the Schema Registry side of things, since we have now 2 versions of this application, of this schema, one came in from the initial, so let's put this to select to compare, and we're gonna do compare with selected. And now I have the ability to see the difference. Now V2 has some additions, and those things are stored inside Schema Registry, and they're versioned, and when the payload will land in Kafka topic, that will include magic byte, what we call it, that will be pointed to schema ID, so the Schema Registry will be able to pick up right schema to deserialize it. All right, so that was example of backward compatibility, meaning that my consumers, old consumer applications will continue to work. My JavaScript application and my Python application continue to work. I also can define a forward compatibility that allows me to update consumers, and the consumers will be able to read old version of producers. And full compatibility, it works both ways. There are certain rules. I'm not going to go deeper into details. Hopefully, this talk will inspire you to go and learn a little bit about this in documentation, because there's a very certain rules that work across, first of all, the serialization format, across Avro, certain rules, and across protobuf, because you can change the names. You cannot change the names. If you try to change the name, it's not going to be backward compatible or forward compatible. So all these rules will be important to take into account. Now, so I showed you a situation where I evolved this schema, so I'm going to skip this demo 3. I just did this manually, so instead of running this automation script, in this demo, I added a few more fields. I regenerate my producer. My producer now producing the version 2, but my consumers, let me actually show you that I didn't break my previous versions. It still received this message. It's a 157, and 157 should be a message that we have in, Jesus, it's not very convenient to do this with one finger. So yes, with the, I have another mic. With this key, we have a new message that was produced with a new version of this schema. And as you can see here, now value metadata also includes not only format, but also includes schema ID. I think it's always included schema ID, right? I might be wrong, but when we go in with Avro, yeah. So inside the value metadata, we also have an ID of schema. So this is how it can retrieve from Schema Registry and know this is the version that we need to use this. It's a part of payload. All right. So we're going to go with the next one. There would be some times when someone decided to kind of like push their changes in order to make sure that the things what they're trying to the build will be executed. And some people just, don't care. They just want to see the world burn. It's just like, yeah, how many of you did git push dash force? Those people, yes, this is us. We just want to see, we're doing this for the love of the game. It's nothing to do with just because. So in this case, here, I would have a scenario where I need to produce schema with something incompatible. And immediately, we start getting interesting things. So Schema Registry has this mode where you can set a compatibility level for the messages that you store this. And this is also part of API. You can see this by default. It has a backward compatibility installed, meaning that, again, all consumers can read new producer messages, some of the new fields. Now, because we have a backward compatibility, we cannot say remove certain fields. We need to do this through maybe one extra version if you're planning to remove this. And usually with the backward compatibility, you can remove, but you need to go +1 version. Meaning that in a new version, you will introduce this field, make it optional, and only remove this in the next schema, so it will disappear. Now, another example, so we're changing types for a particular field that already registered, and we throw in this error. This error comes from Schema Registry. You can see it's red, meaning it's bad. Schema being registered is incompatible with current object value, error type, type mismatch. So you can enforce type checking. So we break in backward compatibility by not providing default value when we're adding this into, we're changing order to order ID. So field remover and addition breaks compatibility. So you can come up with your own scenarios, how you want to break this and how you don't want to break it. So we cannot remove fields, we cannot change types and register new fields. So that's example of how Schema Registry can prevent. Moreover, we do have at Confluent, we do have certain version of Kafka we call it Confluent Platform. And Confluent Platform comes with some additional plugins, for example, server-side schema validation. So like for people who like to do git push force, this will be rejected on the server side. Same thing as you can do this reject on your git side of things, and you can reject do force for push. Schema Registry also can be used to do certain kind of like a filtering. You will not be able to produce. This is more something that comes in Confluent Platform and Confluent Cloud. So the Schema Registry allows you to do cool things not only on the client side but also on the server side. Now, with the Schema Registry, you have what I like to call polyglot harmony. Hopefully, right? So everyone will be using one particular format for your data. Also, you can mix and match. Not inside the topic. Don't mix and match inside the topic. You saw I produced JSON. I produced Java serializable message into topic. Don't do this. It's just for the sake of demos. But you might have different topics where you can register different type of schema. You can have one system would use topics that will use Avro, another system that would use topics that would use protobuf. And also, we do have support for JSON schema. So when I was in the very beginning trying to convince you that JSON is bad, it's not bad. It's okay-ish. And we also have support for JSON schema, but when you define the JSON schema, you're not storing JSON. You're storing some binary representation of the JSON that can be deserializable using the JSON schema. So, Schema Registry is a core piece of infrastructure for your data streaming platform. So the integration with some web services who use data from Kafka, they also can infer some of the format for REST open API specification to define how you will send the message over REST. And it's not nice to have. The reason why you might not have it from the day one, because you just start learning Kafka, you start building your muscles in the Kafka world. But once you start getting into day two, you're already thinking about production, you're thinking that there will be multiple other consumers of this data in your organization. This is where you start putting schemas in place. Automate whenever you have a mundane and not interesting tasks. Speaking of the registration of schemas, once you approve this, once your conversation with other people done, not necessarily with people. You can plug definitely agents. An agent will be able to tell you, it's a good idea or not good idea how to evolve the schema. We do have like MCP server that can talk to Schema Registry, and your agent can make reasons about the schemas that you have there. And try to, if you're not using Schema Registry, try to start playing around with Schema Registry at least on Monday. I know it's going to be a busy week. You're going to be spending time at the conference. But hopefully on Monday when you get back, you just fire up this demo, play around, and start shipping the good software. One more time. Steal this demo, play around with this. Let me know how it works. Let me know if you like it. If you don't like it, there's a special email. It's called dev/null. Fantastically works for me like all the time. And with this, once again, video and slides will be available on this website. If you missed this the first time, I can show you a second time, not a problem. And with this, my name is Viktor Gamov, and as always, have a nice day.